Chapter 7.4 two-tail test. So we know what is one-tail test now. If the probability has increased, then it is one-tail. Then it is one-tail test. So assume H naught is given P equal alpha, and we know that null hypothesis H1 be greater than alpha. So this is the alpha, it is increased. So then we know that with the information, we know that the probability has increased. Then it is going to be one tail. It's no point of looking the one tail, and it is going to be upper tail. So one tail, which is upper, one tailed test. If the probability has decreased, then that is also one tail. One tail test but lower. So we know that H naught is P equal alpha, null hypothesis P alpha, but the alternative P less than alpha. It means we know 100% that that has gone down. We have information mentioning that it is in decrease. But there are situations if the probability has changed, then we don't know whether it is go up or down. So then that we have to check the both sides. That is going to be two-tailed test. So it's still the H naught P equal alpha, but H1 either P greater than alpha or P less than alpha. We don't know that. We only know the probability has changed now. Then only three options: either it is equal to alpha, it is greater than alpha, or less than alpha. So this one we simply write in one term, H1, the alternative to the probability is not equal to alpha. That's how we present two-tail test. So as a result, now you have to check both sides. H1 probability of greater less than alpha and probability of greater than alpha. Lower upper, both tails are in one experiment now. Lower tail and upper tail in one test now. And in terms of significance level, assume in general we give 10% significance level. So then for one tail it is 10%, but for two tail we have to divide to both sides by 5% and 5%. So basically we have to half the significance level. So significance level should be shared equally between two tails. Assume if significance level is alpha, then we are sharing two ways. One is alpha divided by 2 and alpha divided by 2 for upper and lower tail. So another one is there alpha divided by closer to alpha divided by 2 upper tail, and then closer to alpha divided by 2. So then for the critical range, assume probability of x less than less than or equal to C1. C1 is the critical value. So this is less than alpha 2, and this is probability of x greater than or equal to C2 is the critical value less than alpha 2. So it is fixed that that is less than. But if it is in the sum, it is clearly mentioned that if it is closer to alpha by 2, then this is going to be probability of x less than or equal to C1 is closer to alpha by 2, and probability of x greater than or equal to C2 closer to alpha by 2. If it is given significance level alpha, then this is the usual path you have to follow. Otherwise, they will especially mention that if significant is alpha and the tails values closer to closer to that alpha divided by 2. For example, this is 10% alpha. So this is all 5% and 5 less than 5 and less than 5, but this is closer to 5 and closer to 5. This two-tail test we can find in two ways actually. So the first way is with the assistance of expected value. So other one is without the assistance of expected value. So what is this? So from this, with the assistance of expected value, we can bring two tail instead of checking both tails, testing both tails. We are checking only one tail with the assistance of expected value. Now, what is expected value? So I'm trying to give approximate meaning for that. So assume x follow binomial 20 and 0.1. The idea is for a 0.1 mean 1 out of 10 or 10 out of 100. Basically, as a fraction, this is 1 out of 10. So if this is for a 10, 1 out of 10, then for a 20, it is going to be 20 multiplied by 1 out of 10, then that is 2. So this is the expected value. Probability of having a defect product is 0.2. That's 0.4. Another example. What is the meaning of that? 4 out of 10. For 10 items, there are 4 defective. Then, how about for a 40? 40, 4 times 10 out of it is going to be 16. So, that's the idea behind it, the expected value. This is the approximate idea, but so if this is, let's say, 4, for 10 items, 4, then for 20 items, 20 multiplied by 4 out of 10, then that is the answer. So likewise, x follow binomial NP. NP is the probability. So expected value is NP. That's what we did. We multiply by N and the probability 20 times 4 over 10. So now H naught P equal, let's say, beta, particular probability, and then the null hypothesis is P not equal to beta. Now it is going to be two tail. Then x follow binomial NP. The observed value is given. The observed value is x equal simple x. So this is a small testing we have to do. If observed value is less than, okay, I will write in terms of symbol, less than expected value, then use lower tail. If observed value less than expected, if observed value greater than expected value, then use upper tail with uh, this is with alpha by 2. So significant level, assume significance level alpha by 2 with alpha by 2. If it is especially given, then you have to look at closer to alpha by 2. Closer to alpha by 2 if they have given. So either this one or this one, closer to two options according to the sum. The sum will mention, specially mention that. Actually for this one, you don't need to, you can find it straight away. I will show it with the example. The second method is without the assistance of expected value. So when we write critical region, we are writing probability of x less than or equal to c1 less than alpha by 2, and probability of x greater than or equal to c1 c2 less than alpha by 2, and c1 and c2 critical values. Sometimes we have to probability of x less than or c1 closer to alpha divided by 2, and px greater than or equal to c2 closer to alpha divided by 2. If they need in closer to alpha divided by 2, then they will clearly mention in the sum. Otherwise, we have to follow this one. So we'll work with example 6 to both method, and we'll see. In example 6, two restaurants in Enrico's and Manuel's restaurant, and Enrico's restaurant to vegetarian to non-vegetarian to vegetarian, the ratio is 2 to 1. Non-vegetarian to vegetarian. And they want to check that it is applicable to this one as well, Manuel's restaurant. So probability of here, the vegetarian probability is 1 out of 3rd. So they want to check this is applicable to Manuel's restaurant as well. And they did offer random sample of 10, and one person is observed to be vegetarian in here. So we want to test 5% significance level, whether this statement is right or wrong. Both have p equal 1 over 3. Oh no. So x is going to be the number of people in Manuel's restaurant who order vegetarian meal. P is the probability in probability of people vegetarian meal. So X follow binomial 10p. So if H naught is true, okay, now we'll write the hypothesis. So H naught is P equal 1 over third, and the alternative hypothesis is not equal to 1 over third. So this is going to be two-tail test. So if H naught is true, then X should follow binomial 10 1/3. So now we are going to work with the uh, first method. So X equal 1, this is the observed value. Then expected value is NP, n times P, n is 10, and the probability is 1 over third, that is going to be 3.333 dot dot dot. Now we can see that observed value is less than expected value, that is 1 less than 3.333. Observed value is less than expected value, hence lower tail is used for the calculation from the lower tail. So we find the probability of less than or equal to 1. So observed value is 1. That is 0.104, and the hypothesis level is going to be half of it now, because this is two-tailed test, and actually somewhere it is better to write okay, that is half of 5, it is going to be 2.5, it means 0.025. So now you have already worked with the one tail test, lower tail. Now you know what to do. Basically, if it is greater than this value, then it is not in the observed value does not lie. Hence, observed value does not lies in the critical region. Hence, there is no evidence to reject H naught. Hence, there is no evidence that proportion of vegetarian meals proportion mean one third, that the probability at Manuel's restaurant is different to Enrico's. So I rather like to leave another strip here. After that, the significance level is 5%, so 2.5%, 2.5% for each tails. So this is the first method. Check with the help of the expected value. We will find the expected value. If it is lower bound. If it is upper, the observed value greater, then it is going to be upper bound. So it is very simple and easy. Just to summarize, if x is follow binomial in P, then the expected value is in P, n times P. So now we'll apply the second method. X is follow binomial 10 1/3 as usual, and h naught is p equal 1/3, and h1 is p not equal to 1/3, and if h naught is true, h naught is true, x follow binomial 10, this is p, let me write p, 10 1/3, and the significance level 5% or 25% each for both tail. Then the rejection region probability of x less than or equal to c1 is less than alpha by 2, and probability of x greater than or equal to c2 is alpha by 2. So c1 and c2 are critical values. Now we have to find the critical region. We know that this is not something unknown. We use the lower tail. In this, the significance level 5% and 2.5 each for both tails, but it is not closer. It hasn't mentioned in the sum. So lower tail is probability of x less than or equal to 0 is 0.0173. So this value is greater than 0.25. This is 2.5%, or in other way 2.5%. And probability of less than or equal to 1 is going to be 0.1040. That is greater than 0.025. So then we have to stay with this one. So this is the one only applicable. So C1 equal to critical point is now going to be 0. So critical region is also x equals 0. So this is for lower tail. Now we'll work upper tail. So I can see 7 and 6 probability of x greater than or equal to 7 is 1 minus probability of x less than or equal to 6. So this is 1 minus uh, 0. So this is 0.980. This is equal to this one. So this is less than 0.025. And so we will try with 6 now. So up to here, see 0.0197. Now we'll work from 6 up to 6. So probability x less than or equal to 6 is 1 minus x less than or equal to 5. So 1 minus 0.00766 greater than 0.025. Then we clearly see that this is less than 0.025. Then the critical value C2 is going to be 7. Then the critical region is going to be the full critical region x equals 0, critical region x equals 0, and 7 greater than x greater than or equal to 10. Uh, Hence observed value x equal 1 does not lie in the critical region. Hence there is no sufficient evidence to reject H naught. Hence there is no evidence that the proportion of vegetarian meals at Manuel's restaurant is different from Enrico. So in the second method, so this is the setup of the format of the second method, and we find both lower tail and rejection region of both lower tail and upper tail. So this is the critical region or the rejection region. So hence observed value x equal 1, we can see that that is on that region. Hence there's no sufficient evidence to reject. No, reject mean accept. So in here significant level 2.5 each tail, but if you look at exercise 7D when you work 7D7, so you can see that they will especially mention that probability in each tail should be as closer to 2.5 as possible. So we'll see that when we work on that one. So then we want to find the closer one. Let's move to exercise 7D.